Hello, everybody, and welcome to episode 22 of the Hot Path Show. I'm Johnny, joined by me, myself, and I. Although I do see Danny here in the chat. What's going on, Danny? The show is going to be a smooth ride. I hope you guys liked the thumbnail. I had a lot of fun making that one. So anyways, as you can kind of see by the title and thumbnail in today's video, I'm going to be showing you a little kind of flow field, a dots flow field that I've created that I'm kind of using in a little bit of an interesting way to create a basically vehicle AI. I'm really excited for showcasing this for you all today. But we also do have a bunch of really cool other things to talk about. There is a new dots version. I know we just talked about a new dots version last week, but we already are on 1.3 experimental. So there's some cool things to discuss with that. Before we get into it, let me just go ahead and remind you all that in 2 weeks from today, we're getting real close. 2 weeks from today is going to be the first ever Turbo Makes Games Dots Game Jam. So we have done a community event in the past before, but this time we're doing an official actual game jam where I'm going to be tasking you to create a game using Unity Dots and ECS over the course of about 10 days. So it'll span you 2 weekends. So you'll have a good amount of time to do it. And then, once again, on the July 5th episode of the Hot Path Show, so again, 2 weeks from right now, I'm going to be announcing the theme and then, letting you guys on your way for creating something cool. So yeah, looks like we got someone excited for the Dots Game Jam going on. So yeah, very excited to see. Hope you guys are all looking forward to it. And interesting thing with itch.io here though, if we go to the itch.io jams page, it takes a while for them to update the whole big graph thing with the game jam. So if you look at the fifth here and scroll down, I don't see mine on here yet. The same thing kind of happened with the last jam that I hosted on here. It was very close to when the jam started. So hopefully this pops up in time so we can get some more signups. But yeah, we have 28 so far, which is a good number. I think, again, very looking forward to all the games that you all create with this. Okay, so a couple other cool things that I wanted to point out here. We have talked about this before, but do want to remind you all that Unity's Unite event is happening September 18th to the 20th. You can purchase your tickets now. It is happening in Barcelona, Spain, and I will be there. So very much looking forward to that. And I believe it's still kind of within the early bird pricing. So it is a little bit of an expensive conference, but if you do want to get it at the best price, kind of now would be the time to do that. If you're going to be there, looking forward to seeing you all in Barcelona, Spain. Danny, you know if you're going yet? Sure hope you are. Let's see. Another thing that I had mentioned in the past here is the Dots ebook. I do just want to point out that they have posted this here. I believe I have a link for this down in the description. But I think this is a really good introduction into the theory behind Unity's data-oriented technology stack, their entity component system, all the different packages, kind of why it's important to use these things and everything. So if you're still kind of a little bit newer to ECS, I would highly recommend going through this. And so Danny's hoping to come, but not sure yet. All right, fingers crossed. Send good vibes over to the Unity offices, and we'll hope that Danny makes it out there for this one. Unity's been almost turning into a book publisher. They're just pumping out these ebooks like crazy. I think we also mentioned last week that there was an animations ebook that went out. And then just today, there's a new one for 6 tips for porting to Apple Vision Pro. So this one is an ebook here. Let me go ahead and grab this URL and paste it in the chat for y'all. I know we haven't really talked a whole lot about VR stuff on this here, but I do want to do an episode kind of talking about using dots in VR. And I know some people out there are working on some VR projects and everything. So yeah, I just saw this today. I haven't really had a chance to read through it, but yeah, Unity posted another ebook. This one isn't a PDF; it's just like an actual web page, but pretty extensive page with a bunch of tips about porting your game to Apple Vision Pro and some quotes from some of the teams that have actually ported their games to it. Like you see this What the Golf Job Simulator. I think there's like the Lego building one and all kinds of cool stuff like that. So yeah, check it out. Okay. So with that, I do just want to remind you all that if you do want to, you can support us over on Patreon. We have some cool perks over there. I know we have the Dots Game Jam coming up. So if you are at the L1 cash tier or higher, then I will be kind of prioritizing playing those games for people who have submitted those, if they're kind of at that support tier, on a live stream coming up kind of like after the jam happens. Also, I did just post a Q&A, a request for questions, so you can basically ask me anything that you want, whether it be related to DOTS, ECS, game development, or just kind of any random other questions you might have for me. So if you are at the L2 cash tier or higher, again, you can support us over on Patreon. There's a link down below for that. Or you can support us through YouTube memberships just with a little join button down below this video. Basically, all the same support levels are exactly the same on Patreon or YouTube. So it's just kind of wherever you'd like to support us is very much appreciated. And then, yeah, we also have other cool bonus videos and stuff. So we'll be getting, as we're getting towards the end of the month, we'll be getting those bonuses for this month out for y'all very, very soon. Okay. So with that, we can kind of move into some of our things here. I'm going to go ahead and do the context switch actually here. So context switch, this is kind of where we talk about, some kind of a little bit more interesting ECS topics and all of this. So I did just briefly mention at the beginning of the show, but we do have a new version of Unity ECS. This is version 1.3.0 experimental 0.1. Yeah, these experimental versions, these are kind of like the first release of kind of a newer version, the first kind of public release where they're starting to get those out into the wild, get people playing around with them, making sure that there's no kind of major bugs or anything like that. But it's still considered a little bit more kind of on the cutting edge. So if you're working on an actual project, this is probably not going to be one that you want to upgrade to. But if you're starting a new project and some of these features sound nice to you, then it could be worth it to go ahead and just kind of experiment with. Okay, so I just kind of want to go through this because there's actually a lot of really interesting things in here. So going through the added section, so these are kind of new features in this version 1.3. So we have this archetype chunk.getEnabled mask, which now allows creating masks from buffer type handle, dynamic component type handle, in addition to component type handle. Now I had to look up this enabled mask. I'm not like super familiar with what it is. I know it's kind of like the back end thing of basically how like enable bits work. But from what I understand, this is just kind of like giving us lower level access to certain things, particularly related to the enabled mask for enableable components. So it can kind of just give you different ways to I guess kind of determine if certain things are enabled or not, kind of again at like a lower level, and kind of give you maybe some more options to determine how you want to kind of interpret that and use that in your project. So of course we can already check whether a component is enabled or disabled for a given entity, but again this is kind of like a lower level thing, kind of at the chunk level, where we almost get the whole bit field of which components for which entities are enabled or not. So, not something that I really have any amazing use cases for right away, but again, it's just kind of nice that we have access to some of these kind of lower level functions to, in the rare cases that we might need them. So another one here is the enabled ref RW and enabled ref RO can now be created from iBuffer element data, either from an enabled mask or a buffer lookup. So the enabled ref RW and ref RO. I think we briefly mentioned these in a previous episode. It's basically a way that you can kind of enable or disable components by setting a true false value on them. So looks like we can do that with iBuffer element data, and we can actually get these from different places like this enabled mask or the buffered lookup. So there is a new variant of the entity manager.getComponentOrder version that targets a runtime component value instead of a compile time type parameter. So these component versions, basically this is kind of how Unity under the hood like essentially tracks changes to components. So these components are going to have a version number associated with them, and I believe this happens at the chunk level. And basically what happens is anytime this component is opened for write access, this version number is going to increment. Now the kind of reasoning behind this is that's so we can kind of compare the previous version to the current version. And if the current version is greater than the previous version, then we know that that component has been opened for write access for some point. And then so we can already, Unity kind of already basically allows us to determine if a component has been opened for write access through the, you can basically just say, hey, did this change? I forget, I can't think of the exact method off the top of my head right now, but you can see that basically if that component was opened for write access. So basically what this specific function allows us to do is it actually allows us to get the actual version number, so we could maybe do some comparisons on our own. Maybe we say, oh, this component has been open for write access 6 times. Let's handle that in some interesting way if you wanted to. I think this thing was kind of like already available to us, but again, they just kind of added a new variant where it targets a component type rather than this compile time type parameter. So just a slight variation on there. Now this one is actually super interesting here because I wasn't really aware of this myself, but for entity queries, there previously was a get entity query DESC, but now there is a get entity query DESCS. So the DESC is short for description. For some reason, they chose to shorten this name. In a lot of the other, API things, they still have the full long name, but for whatever reason, they wanted to shorten the word description. But anyways, so the entity query description is kind of like it's kind of like one way that you can define an entity query is you can create these entity query descriptions and get an entity query from that. Now this is kind of like the reverse for that, where you have the entity query and then you get the entity query description from that. Now, I guess what I didn't really know, just kind of like how this kind of works under the hood, is that an entity query can actually have multiple entity query descriptions, which kind of makes sense, I guess. Because there's different ways that you can kind of get to the same entity query, I suppose. So this is kind of interesting because it actually gives you a list of all the entity query descriptions for this entity query, rather than just the one particular entity query description. And actually, if we go down a little bit, they did actually deprecate the previous get entity query description, so this should no longer be used because it only returns the target query's first query description element. So it says use the new one. And kind of interesting syntax, if you just need the first one, you can do query.getEntityQuery DESCS parentheses, and then after that you can do a 0 on the indexer to just get that first entity query description. Now, I wonder what the use case is meant for. I kind of wonder that myself as well. I haven't necessarily had the need to have a query and then like get the entity query description from it, but it's available to us if we need it. Because again, for the most part, I use entity query descriptions for creating entity queries. And if I already have the entity query, I'm not sure what the value of, um, you know, getting the entity query. I guess maybe the only advantage would be like you have query A, you get the query description, make some modifications to that, and then create entity query B after that. So that's something that I guess you could kind of maybe do at runtime or something. So, if you want to get real crazy with entity queries, but I haven't really had a need to do that. So, anyways, added new entity manager, maybe some type of code gen. Yeah, potentially. Yeah, again, I guess that could kind of be, going along the lines of, getting the entity query description. Code gen doesn't use it. All right. Fair enough. Okay, so let's see. We have a new entity manager dot set shared component type T on the archetype chunk. So this one's actually super nice because what this does is this changes the value of a shared component for all entities in a given archetype chunk. So if you're familiar with shared components, basically it is, you can think of it as one value of a component that's shared by all entities within a particular block of memory. A lot of advantages to this, one of them being just kind of reducing the memory footprint because you don't have to, say, duplicate data across a bunch of different entities. You can also use it for kind of organizing, breaking up specific entities into specific queries. Maybe you want to have like all the entities in the red team be in one block of memory and all the entities in the blue team be in another block of memory. So you can do that through shared components as well. So this is cool because it allows us to basically change the value for all entities in a given chunk at once, rather than going through them, one by one and changing them all. So it's a little bit more efficient version of that. Now, the next thing that we need is an ability to arbitrarily get the shared component value of an entity, especially within jobs and other things. Like, we have some entity, we want to know the value of a shared component. Unfortunately, it's not always the easiest thing to do. So yeah, it would be nice to have a get shared components type thing. That's something that I've been kind of wanting as well. So Danny says, I have no clue what it does, but I'm sure there was an incident report that caused us to change it. Otherwise, likely we wouldn't have changed it. Fair enough. Yeah, so entity storage info lookup. And I think we talked about this on a previous episode briefly, but again, kind of weird how it's a little bit of a roundabout way, but it still allows us to get the chunk, and then we get the shared component from that. So, thought my AC turned off for a second. It's kind of warm outside today, so definitely want to make sure that that's on. Okay, speaking of, let me have a sip of some hot tea here. Okay, so going into the changed section. A couple interesting little optimizations they did. So the internal buffer capacity for child buffer components was previously at 8, and now it's down to 0. Kind of the advantage of this is to reduce the memory footprint for any entities that have a buffer of children. Because previously, even if you only had one child, it would still allocate memory for 8 child entities, which kind of adds up, especially if you most often just have, like 1 or maybe 2 children components. So, definitely just kind of good reducing the memory utilization there. So now I guess the only disadvantage of this is that the actual like entity reference isn't going to be stored in the same chunk as the actual entity. So it's going to be stored somewhere else. There's going to be like, a pointer to it or whatever. So, just a small, I guess, little inefficiency when dealing with children components, but, not too bad. It would be nice if there was a way that, like, we could choose how to actually set this without, of course, modifying the source code. Let's see. By the way, glad you like the thumbnail. I buy ice creams when it's raining, so can't judge the tea. Fair enough, fair enough. Hey, and we got Wayne Games here. What's going on? All right, so yeah, we're just going through again the new version of Entities 1.3 Experimental 1. So next item here in the changed list is the internal capacity for the linked entity group. This previously was 1, now this is set to 0. So pretty much same thing as before for the child entities, but now this is for the linked entity group. So again, to kind of improve the default chunk utilization of prefabs and prefab instances. Okay, so here's just a quick little renaming one about things related to the enabled mask. Entity query get combined component order version now takes a bool parameter to indicate whether the entity component should be included. So again, this kind of goes back to some of these component version numbers where we can see what has been changed and not. So this is cool here. Improved performance of the local to world system when processing entity transform hierarchies by distributing work more evenly across worker threads. Haven't gotten a chance to actually test this because I literally just saw that this new version was available like an hour before I went live here. But I do think that this is related to something that I had shown in a video kind of early on where when dealing with the transform systems, if we have, say, like one parent entity and 1,000 child entities, all those transforms for all the child entities have to be calculated on a single thread, all on the main thread. Which is a little bit unfortunate. So again, I'm not sure exactly if this is a solution to this or if this is just kind of like talking more generally about transform hierarchies for just kind of distributing the work across worker threads. But I think that's a good thing. It's something that I would like to test a little bit more to see kind of what's going on. What is this? Non-JE has an E, and I'm nowhere rich or enough to compete. Not sure what that's all about. I'm confused. Anyways. I already mentioned this before, but the entity query description is now deprecated in favor of the get entity query descriptions. Again, the list of entity query descriptions. They also removed the enable mask constructor from the public API. Its inclusion was an error, and it's impossible to call safely from user code. The correct way to create these is through archetype chunk.getEnableMask. Coolio. Okay, and then, there's nothing crazy, not too much crazy interesting in the fixed category, but I do just want to call out that creating an entity query with multiple entity query descriptions or by using entity query builder.add additional query now correctly matches archetypes that match one of the query descriptions other than the first. I don't remember why I highlighted that to point it out, but enjoy that fact. Entities windows no longer throw exceptions when installing or removing packages from the package manager. Glad that we finally got here to episode entities version 1.3. So yeah, enjoy no longer having errors being installed when you install packages. Hello, Leo. Welcome in. All right. So, yeah, again, enjoy playing around with the new Entities version 1.3 experimental this weekend. Yeah, I'm sure I'll probably have fun experimenting around with it. I do want to check out, what's going on with the improved performance in the local to world system and see if that's, something that I can kind of noticeably see a difference. So that would be cool. Okay, what is next here? Okay, I think next we can go ahead and go into our cache hit, which is the Unity Dots quick tip of the week. So here we can kind of pull up this little project that I'm going to be showcasing for kind of the main portion of the show today. So one thing that I do just want to point out is just kind of like a little tip / reminder about when exactly baking happens, because this is kind of like an important thing to understand. So basically, baking, of course, is when we have, say, well, I don't want to do this right now because this is kind of what I'm showing, but so we have, say, an entity scene here, and then we have, just kind of like regular game objects, of course, within our entity subscene. And then on here, we can have, all these authoring components, custom components that we made. And then at certain points, this baking essentially happens where it, takes all this data that's inside the authoring side, and then it bakes it over into ECS compatible data. So it is kind of important to understand like when this baking happens, because it can kind of like help you optimize your development a little bit. So I have this scene here where, I'll just go ahead and do play focused for now. So we can see, we can go ahead and hit the play mode, and pretty much right away, actually, let me get rid of this stats thing here for you. And then I'll just show you again. So we're basically kind of in just the regular scene here. Go ahead and hit play, and we're pretty much right in the game. We can play, we can drive around, yada, 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 having a great time. Now, something that I'm going to be getting into is sort of how I created this whole flow field setup and everything. So let me actually go ahead and hit the check mark next to the entity scene to actually load this in. And you see that this is actually going to take a little bit of a while. So yeah, basically what's happening is I have a really inefficient step in my baking right now, and it makes things kind of annoying to deal with. So basically what I have here is I have a spline that's kind of sitting in the sub scene. The spline is just kind of like how I can define what the kind of like track is. It's probably gonna be hard to see, but there's like a little yellow line that's kind of going around this track here. And then, of course, it has, all these points and everything. So then I have this flow field controller, which has a reference to this spline. And then in the flow field authoring, which I'll be showing in a little bit here, what this does is it goes to every single point in the flow field, and then it kind of determines where on the spline is it's closest to. And then basically it's going to kind of have its like initial value point towards that point on the spline, but then depending on how close or far it is from the spline, it'll kind of shift it again a little bit towards the direction of the spline. So basically, like when you're right on the spline, in theory you should be, the flow field should be going directly forward, where if you're like far out, like 10 units out from the spline, then it should basically be like pointing you perpendicular to the spline to like kind of get the AI controllers to go back towards the spline for the lap here. So doing this, because basically we have to go through 150 by 150 cells, comparing on every single point on the spline, and this spline is, an unmanaged spline, or a managed spline rather. So it's not like, super efficient getting all the points from it. This is all main threaded. So now if I hit the play button, you're gonna see what happens is it takes a long while to enter play mode. So we're basically just sitting here and sitting here and sitting here. And the reason that we're doing this is because it's kind of going through the baking process right now because I have the scene loaded. And then it finally loads here. So then now we're in here. And then we say, okay, oh shoot, something messed up. Let me go ahead and, exit play mode. All right, it's going to take a little while to exit play mode. I don't think it should do a baking step after, but, for some reason it's taking a lot longer to exit play mode and exit play mode and exit play mode. Okay, and here we are. And then, yeah, same thing if we were to say like, make a change and, I'll even demonstrate not even making a change. Go ahead and enter play mode. And then now we have to wait and wait and wait. So again, this is because this baking step is happening when we're entering play mode, when we have the sub scene open like this. And then, so yeah, basically, the kind of optimization that I took was to basically just close the sub scene for, times that I don't need to edit it. And then, if we do ever need to like make some modifications to this, like let me go ahead and set this max distance to like 10.5. Now, when I just change that value, you see the whole thing froze up. It's got to recalculate all these points on the spline, and it just takes a long time. So yeah, it's basically because the sub scene is open that it's kind of rebaking when we enter play mode, and then the baking step happens again every time a authoring component is edited, and we can only do that when the sub scene is open. We can't change the authoring if the sub scene is closed. So yeah, that's definitely just like, one thing that I want to point out is kind of make sure you understand when baking happens. Again, it's going to be happening if the sub scene's open when we're first entering into the scene, and it's also going to happen anytime we make any modifications to the script here. So, hopefully that kind of helps you, go about changing maybe your workflow a little bit. And I don't think if I go to say this like vehicle controller, if I like change the top speed of this to like, 510, you see it doesn't do that whole rebaking because it's only rebaking the entity that you're editing. So if you have some like, really intensive baking process, make sure that you're only, doing that in the times that you need to, and try avoid, doing it over and over and over again. And then, I haven't really dove too deep into like using multiple sub scenes for things, but I think one potential option could be, using an additional sub scene to kind of have maybe like some of more your intense calculations in that one. But then maybe you get into some weird cross scene reference things here. But Wayne Games also says a tip here. You can keep the sub scene closed if you relied on a scriptable object to define your data and have the baker declare it depends on it. So yeah, that is another option as well. So yeah, I mean, again, it's just kind of like one of those things where, if your baking process is like it's taking a while to enter play mode. And again, I do have all the, fast enter play mode settings set up correctly and everything like that. Definitely could just be like one thing to look into, kind of optimizing your baking steps. Okay, so that's just kind of what I wanted to point out there. So now we can kind of get into, of course, it's going to go through the whole exit play mode step here. We'll go ahead and get into the instruction set, which is kind of the main topic of today's show, which is going to be vehicle AI controlled with a dots flow field. By the way, I do just want to kind of point this out. Do you think it's possible for, you mentioned the agent's navigation assets. Do you think it's possible to apply this asset, or should I write something similar to what you're demonstrating? So I'm demonstrating something a little bit unique here. Let me kind of like talk you through, I guess, a little bit of the theory about what I'm essentially doing here. So most often when you have flow field pathfinding, it's going to be, I guess, like traditionally, it's going to be like when you have, say, like a group of entities in like a real-time strategy game, and then you want to move all those entities to a single point on a map. So maybe you have like, all these entities, you want to like target the opponent's base or something like that. All right, we got thunder outside. I was not expecting that. Um, so it's still rolling. All right. What was I talking about? Flow fields. So if we have like a real-time strategy game and we have like units all over the map and we want to say give an all-out attack on the opponent's base, well, we can generate a flow field which basically just points all the units no matter where they are to this one point on the map. So what I'm doing here is a little bit interesting because rather than having all the entities go to one point, which is kind of like what like the agent's navigation asset and things do, I'm doing, again, something a little bit custom where, again, I kind of have this spline defined. It's probably really hard for you to see, but it's kind of a blue line now. So if we kind of go in here, yeah, I mean, we're not really seeing this here, but yeah, basically it is, yeah, just kind of like goes in a lap. We kind of define all these curves and everything. And again, this is what I'm kind of like considering as like, say, like the center point of the track, or maybe, the most optimal path that people want to follow, essentially. So again, what's happening is, and what I'm going to be demonstrating is how we kind of first generate the flow field. Again, just by going through all these cells in this grid. So I've basically broken up this world into a grid. And then, we're going to test each cell against a point on the spline and then say, hey, what is the closest point to it? So we can first kind of, point to that closest point. And then we're also going to check the distance that cell is from the spline. And again, if it's further away, we're going to point directly towards the spline. And then if we're closer, even like right on the spline itself, we're going to point in the direction of the spline. So that way, basically, and actually I can even just demonstrate this to y'all here. What I'll do is I'll exit the subscene, and I don't need to save that. And we can go ahead and enter play mode here. So we can see when this flow field is generated, kind of what happens here. So I have all these little arrows to just give us a little bit of idea of what's going on. So you can see that, kind of in the center right here, where, it's going to direct entities to basically go straight forward. And then as we kind of go out to the side, you see that these arrows kind of more point towards inwards. So it basically makes the cars kind of follow this main line. Now, I need to do a little bit of adjustments on the car controllers here because they do like to drift quite a bit and they hit these cones and fly in the air. So it's all fun. But yeah, I mean, you can see it's really cool because like we're coming up around the curve. We get a nice little drift around the curve here. Of course, these guys are all, completely AI controlled and everything like that, because all they're really doing is just following this flow field. So you see that, when you're over here, they're going to kind of point them towards sort of the center here. And then we kind of come up around this curve. And you see we're kind of going this way now. Ooh. And yeah, kind of come back up this way. And yeah, you just kind of follow the whole spline around it. By the way, that's a great name, Tokyo Dots. I can't believe I didn't think of that. So yeah, this is kind of basically what I'm going to be showcasing here today. So I'm going to be showing kind of like how I created these little vehicle controllers, as well as the whole little flow field spline setup. So I kind of showed off the, so the spline is like a racing line in theory. Theoretically, if you wanted two cars to drive alongside each other while avoiding contact, would you set up two different splines or define an offset? Basically right now how I have this set up is, all the AI entities, they're going to be, trying their best to kind of navigate to that kind of main spline path. If you wanted something, authored a little bit better, then yeah, maybe you could do some kind of, you can definitely have multiple flow fields go on at once. Because again, the kind of nice thing about this is the flow field is only calculated once at the beginning. That's that step that kind of like takes a while to actually enter play mode and all that. But once the flow field has been like generated and defined, all we need to do is just sample it. And so there's nothing stopping us from, say, having multiple flow fields that different entities could sample from. The way that I wanted to create this game is, them just all sampling one. So they're all kind of like, fighting for that main line. And so, yeah, I have some interesting ideas for this project. I'm doing a little bit of a collaboration with some other creators for this project. So I have some cool ideas for how this project is going to turn out. This is actually pretty early stages. It's not that difficult actually to create this flow field, which I'll be kind of demonstrating here today. But yeah, I think things will start to get a little bit more hectic when I kind of build out this idea a little bit more. So that'll definitely be fun. But yeah, I mean, it totally depends on how you want to define it. You could have multiple different splines, or maybe even a little bit more complex AI where, yeah, like entities are going to prefer to follow the flow field, but then also there maybe could do like a distance check against some of the other cars in the surrounding area, and then have them kind of prefer to kind of navigate around them rather than just trying to bump each other off the track constantly. So there's different ways that you can handle that however you want to. Okay, so I guess I'll start with the vehicle controller here. So I guess this would be under vehicle authoring. Actually, I probably should have the vehicle AI authoring open as well, because I do want to go ahead and do this, and we can do this here as well. So yeah, by the way, I'm using the A-line asset to draw all the kind of like grids and arrows and all these kind of things that I'll be showing you here today. So yeah, I really do like that. So Wayne Games says you should separate the spline of the AI from the spline of the road, so you can define the AI spline to follow the ideal racing track. Yeah, that makes sense. Yeah. I guess what I'm showing here is just kind of like with the like just some cones, and just kind of had like a the ideal line kind of going around that. But yeah, I totally know what you mean. You don't want to, like, it's not always going to be optimal for the AI to like follow the center of the road. Of course, you want to kind of like cut through the corners and everything like that. Okay. Oh no, entity scene failed. Let's see if we can hit the check mark and wait for the baking to load it in. None, I might have to restart Unity, which would be annoying. Okay, that looks good to me. So what I wanted to showcase here is how these vehicles actually work. And just gotta wait for the baking. Okay, so you can see that all these vehicles are really just giant rolling spheres. So yeah, this is basically kind of what they are, is really they're just kind of a rolling ball, and the car is really just kind of it's actually a separate entity than the vehicle controller. It's just kind of for the visuals. It basically just kind of, well, so the way that it works is, of course, when you're going to be driving in a straight line, it's just going to add force directly. And then when you want to turn, it kind of has like a steering variable, and it kind of, you point your steering variable in the direction that you want to turn. And then, we kind of start adding forces to roll the ball kind of towards that direction. So, and of course this works, exactly the same between having the manual vehicle controller, where I'm actually putting in inputs, versus, what I'm also going to be showing, where we're sampling the flow field, and it's kind of, changing the trajectory of how these cars move and everything. So it's a very simple way to do a quick and dirty vehicle controller. You don't have to worry about any kind of crazy ray casting against the ground. And I think it gives like a good little arcadey feel, and there's a lot of drift built in by default, so probably going to tune that down a little bit. So, yeah, we could go into like the vehicle authoring. Of course, we have, just kind of like some simple things for the vehicle properties, what the, current steering, top speed, acceleration, everything like that is. We also do have a separate entity for the actual visuals, which is, the actual kind of car there for sure. So the vehicle authoring here, of course, this is pretty simple. We're just kind of directly setting values, not doing anything crazy in there. So yeah, the player vehicle movement system, this is kind of, the player controlled vehicle, how this kind of all works here is, we see here, we're just kind of doing our idiomatic for each here, of course, looking for things with the player controlled tag. Actually, one little optimization with this that I probably could end up making at some point is, right now you'll see that I'm just kind of like directly reading in player input, but there's nothing stopping us from like kind of going a level past that where, yeah, we have our player input, but we can kind of like make that almost the same as if we were to sample it for the vehicle AI stuff. So right now I have a separate system for all the vehicle AI where it kind of, samples the flow field and, tells the car how to move. But the cars are really moving in the same way. We're still adding forces to the sphere at the end of the day. So one thing that I might do just kind of for, the interest of doing it this way is, kind of having some separate system that says, takes our player input and then puts it into some like kind of vehicle input component maybe. And then that vehicle input component determines how the car actually behaves. And then similarly, I would have a different system where all the flow field entities sample the flow field, and then they write to that same vehicle input component, and of course, can be handled by the exact same system for vehicle control. So I think that would be a fun little exercise to do. But right now, they're separate systems just because it's easier to kind of prototype things that way. So of course, yeah, just looking at the player input for the X direction. So I basically have this current steering, and then it's just kind of like, whichever way the player is steering, it's going to, add or subtract to this value. And then basically from this current steering value, this is kind of where we calculate the kind of like, direction of movement basically. So, yeah, kind of what I'm doing here is just like a little bit of like debugging so I can like, have a line to see, what direction that it's in. But yeah, that doesn't really matter too much because later on I'm actually, putting the visuals of that steering against the car. So that was kind of like earlier in the beginning when I didn't have like a car synchronized up to the steering quite yet. And then so this goes into, actually doing the acceleration. So we take the acceleration value in our vehicle properties, and then we multiply that by the player input.movement.y, which is either going to be basically 1 if we're going forward or -1 if we're going backward. And then so we actually create a float 3 off that, setting the current acceleration in the X direction. And then we can do a little bit of like a rotation here to get the steering quaternion by doing a axis angle. So the axis we're rotating about is going to be math.up, and then the angle is going to be the radian value of our current steering. So current steering is basically stored in degrees, and then we can kind of move that over to radians. And then we actually kind of apply the rotation. So the steering, we do a math.rotate against the steering and the rotation. And then here I do a little bit of interesting things. This is actually something that I found, I think I talked about this last week a little bit about how you can kind of dive into some of the physics packages to see how things are kind of working under the hood. One thing that I sort of came across is this ability to apply different forces in world space. And so what I can do here is, I get this world space by doing a math.mul, taking the transform.rotation, so the current rotation of the object, by the mass.inertia orientation. And then from here, I can rotate the basically inverse of that by this previous rotation that we calculated. And then this basically gives us kind of like a world space rotation. And then we can actually apply an angular impulse against this. So again, this is kind of one of these extension methods that I talked about last week about, how we actually kind of apply that angular impulse. So really all this does is, it is kind of a couple extra math steps, but really all it does is it's just like, whichever way the vehicle's current steering is facing, we're just going to apply a world space impulse in that direction. Which works pretty well for this simple car controller. Then what I'm doing here is, if the player is not pressing down on the movement input, this just kind of slows the vehicle down. So it just kind of applies impulse in the opposite direction. So, I mean, I'm not going to show it right now, but basically it's just going to slow the car down pretty quickly. Whereas if we didn't have this, then it's just going to kind of keep rolling and then rely on the Unity physics friction to slow it down. And I would just rather kind of have a little bit more control over this here. Here's just something to limit the angular velocity, just so we're not going past the top speed here. Pretty easy. We just check to see if the length of the vector is greater than the top speed. If it is, just go ahead and normalize that and multiply it by the top speed, and then just manually set that angular velocity right in there. So it's just kind of a way to limit that vector. And then this last portion here is where we just kind of are like actually setting the transform of the visual representation of the car. So again, this car is kind of like a separate entity, and then we're setting the position to basically be at the center of the sphere minus some offset, so it's kind of shows up on the ground. And then we also want to rotate it whichever current direction that the vehicle is facing, or the curve steer value is facing. And then so then this is actually how we can display these spheres on the screen. Again, this is using the A-line asset. So it has me kind of create a draw manager builder here. And then what I'm doing is I can do a push matrix, and I basically take the transform and then do a to matrix here. And then I can draw a wire sphere at float 3.0. And again, because we push that matrix, it's going to have the essentially position and rotation of that transform kind of already baked into the A-line asset. So then that's how we can actually see how the sphere is rolling throughout the world there. So it's kind of nice. And then we just do a pop matrix after that to pop it off the stack, because we no longer really care about that value after that. So yeah, that's just kind of like a quick little overview of the vehicle controller. As you can imagine, the AI controller, it does something very similar, but the only real difference is we're actually sampling the flow field. So now I think would be a good time to actually go into the flow field and show you how this all works here. Grab a quick sip of water. All right, by the way, if you're enjoying today's stream, make sure you hit that like button. Okay. Flow fields. So the way that I've chosen to implement flow fields is by doing a blob array of these flow field cells. So this flow field cell is just a regular struct, nothing special about it, nothing entities about it. It has two public float threes, one for a position and one for a direction. So position is kind of the world space position. I use this for just, a couple calculation things down the line. And of course, direction is going to be the direction that cell is pointing. So whenever an AI is above a given cell, which direction should it kind of move to, basically, is all this is saying. So just have another regular struct for the flow field itself. And then the value of this is a blob array of type flow field cell. Again, we've talked a little bit about blob arrays in previous episodes, and I do have some videos on my channel about how blob assets work and all this. But it's basically just kind of like an array of immutable data. So again, the advantage of this is we calculate it once at the beginning of the baking steps or whatever. By the way, one other thing I wanted to point out on baking is that when we actually go to create a build of our game, that baking step happens during the build process. So, when a player enters our game, they're not going to load for 10 minutes while it's just calculating this flow field. That's already been baked into the build. Of course, if you're having procedural generation, you're going to have to, create some of that stuff at runtime. So that's kind of, again, another thing to consider. So yeah, we just have kind of this array of all these cells. And then of course we can't do a two-dimensional array. So we have to kind of, flatten the array. So even though I have a big grid of cells, these all have to be in one single flat array. And so there's kind of some interesting tricks that are pretty common that you can do to basically kind of, key into that array based off of the XY coordinates. So here is the actual component that's going to be added to a single entity. So I've called this the flow field blob. So this has a blob asset reference of type flow field. Again, this is just this flow field right here. And then we also kind of have some other properties about, what the grid size is. Again, this is 150 by 150. The cell size, I believe, is set to 2. The center point, it's just kind of like the, if the map was kind of shifted over, we could maybe, adjust the center point of the map. And then also have this max distance. And this max distance here is actually what kind of determines how far away from that center spline you are. That max distance is basically going to be when you're kind of, the arrows are perpendicular to, facing the spline, as opposed to, at 0 units away, the cells should be facing in the same direction as the spline. We'll get into all that stuff in a sec there though. But it's actually grayed out here because I don't think I'm using this during runtime yet. I'm really only using it during the authoring and baking step actually right now. And then kind of have some little helper functions here for getting the half grid dimensions, which is helpful for doing a get cell at position. So this is a little helper method that I've created. And with these iComponent datas, again, the purpose is to store just data on them. But we can have little helper functions on here for us to, do a get cell at position, where we basically pass in this position. It does a little bit of calculation to figure out kind of the coordinates of that cell. So once we have the cell coordinates, then what I've done is created a custom indexer. So you can see I'm doing return this at cell coordinates. And then, so this is how the custom indexer is set up, where we just say we're returning a flow field cell. This is a public read only. Again, returning a flow field cell. And we just say this, and then we do the kind of square brackets here, and we can put in whatever we want for a custom indexer. So if you wanted just a single int as a custom indexer, you could put that in. Also, we have the int2 in this case. And then, so what this does is now this actually dives in. You see it does a value.value.cells. So if we kind of follow this down, so again, this is happening on this. So this goes into the blob asset reference of flow field, which of course is this right here. Um, I think there's like an extra value at some point for the blob asset array or whatever. But so yeah, it dives into this flow field, and then we actually get the cells here. And then again, the cells, this is an array, so we can just kind of key into this array as we would any normal array. And then what we can do here is do our grid size.y multiplied by coordinates.y plus coordinates.x. And then that basically converts that 2D coordinate to a 1D flat coordinate there. So again, it just kind of keys right into the array. And that again will basically just return us that whatever cell at this current position here, and then returns that. So that's basically kind of how that works there. Flow field drawer. This is just kind of a separate system that I have set up to basically draw the grid and draw all the arrows with the cell direction. So again, this is a lot of just kind of like A-line stuff happening within here. By the way, I don't have the code for this available online right now, but when this project is complete, I think what I'm going to try and do is kind of separate out all the A-line stuff and some of the other packages that I'm using into its own kind of separate thing, so that I can kind of have all the code and everything sort of publicly available for people if they do want to check this out. But that'll probably be happening that actually probably won't be for another couple weeks, probably after the game jam actually. So yeah, this flow field authoring, this is basically where the whole kind of calculation for the flow field happens. By the way, this mono behavior gizmos, again, this is part of the A-line asset. I'm kind of doing some additional gizmo drawing stuff in here. But so yeah, we don't need to worry about that. I'm probably not going to go into that there too much. But again, yeah, this is kind of where we define some things about the map dimensions, the cell size, that current spline, how we're actually define the main path of the track, and then that kind of like maximum distance from the center. So basically what's happening within the baker here, again, this is kind of where a lot of the heavy kind of calculations are happening, but we're doing just kind of some basic things. Again, we're figuring out what the grid size are. So the map dimensions, this is a float too, so we say that this is a 300 by 300 area, and our cell size is 2 units. Then what we're doing here is we're kind of figuring out how many grid cells that this should map to. In this case, it's 150 by 150. And then, get the total size. I guess total size, I could probably just do the map dimensions. I don't know why I did a extra thing there. Anyways, then kind of using the half grid size and half cell size, this helps us do some calculations and figuring out the positions of things a little later on. And this is where we actually kind of start creating our blob asset. So we use a blob builder. We just need to do a temporary allocation on here because we're disposing it when we're done building it. And then here we actually create the construct root of the flow field. So we have this flow field here. And then we can do a array builder.allocate, doing a reference to the flow field.cells. And then the size of this is grid size.x times grid size.y, because again, it's going to be a flat array. And of course, we can get the number of cells just by doing, x by y. So then we basically iterate through the cells in the x direction and the cells in the y direction. And then, go ahead and figure out what the position of that cell is going to be. So we can kind of take the x value, multiply that by the cell size, take the y value, multiply that by the cell size, and then just kind of do a little bit of adjustments, again, kind of based off of where the center point of that grid is and how big the cells are. So essentially the position value is going to be the center of any given cell. So with that, once we have that position, now here's where we do kind of the heavy calculation portion here, where we do the spline utility dot get nearest point. So here we can pass in the spline, which again we have from the authoring component. We also pass in the test position. We have a couple out variables here. So there's a out var closest position. So the closest position is a float 3, and that gives us basically the closest actual point on the spline, and we can kind of use that for some things later on. And then we also have this t value. So this t value, I believe, is if you think of the whole spline, that whole lap, as like a 0 to 1, where 0 is kind of at the start point and 1 is at the end point. Even though in this case, because it's a lap, the start and end point are going to be the same. But any t value is going to be kind of like a percentage along that spline, again from 0 to 1, which helps us for something in just a sec here. Then these last two variables that I'm passing in here kind of help are a little bit of like an optimization, where lower numbers, it's going to be a quicker calculation, but it will give you less accurate results. However, higher numbers are going to be more expensive, take longer to calculate, but give you more accurate results. I've opted to basically set these as the maximum default values. I don't know if it can actually go higher. I haven't really looked into it, but there's kind of some like maximum values defined. And so anyways, I set them at those maximum values just because, again, when we're actually going to ship this game, this baking step isn't going to happen. This is already going to be baked into the application. So it's just better for us to create a more accurate, have more accurate calculations during this baking step, and then just kind of, have that accuracy be baked into the build. So yeah, and then actually this just returns the distance. So we don't need to do any additional distance checking based off of the current position and closest point on the spline. So this is kind of handy for us to do some things here. So again, this just kind of figures out, again, from any given cell, how far is it to the nearest point on the spline, and what that closest point actually is. So what we can do here is we can do closest spline direction. So I basically normalize, so what this does here is now we take that t value, which is that 0 to 1 on the spline, so we can kind of figure out what the tangent is at any given point along the spline. The tangent is basically just the direction that the spline is facing. So this, again, kind of allows us to, when we're close to the spline, we can have these cells face in the same direction as the spline. The next thing that we're going to be doing on the line after that is getting the direction to the closest point. And that's just some, simple vector math, doing closest point minus the position of that cell. And then, of course, we just normalize that to get the direction, because we don't really care about the magnitude at this point. We're really just caring about the current direction. So what I can do here is I have I found out this interesting thing here. There's a math.unlerp. So this does basically the opposite of a lerp, where I guess, how do I explain this? So like a lerp, is a linear interpolation between, one value and another value, and then you pass in a t value, and it kind of gives you that percentage between those essentially. So this is kind of the opposite, where it's basically, you can pass in the, again, the minimum value, the maximum value, and then rather than a t value, we do the distance to closest point, and then it basically returns us the t value. So if we were to say do a lerp function of the 0 to max distance using this value that's calculated, it would return us this distance to closest point. So it's basically a way that we can calculate that t value, from the minimum, the maximum, and the current value. So I thought that was kind of cool. I didn't know about this math.unlerp function, and I happened to come across it, and I was like, oh, you know what? I can use this here. So it's kind of cool there. And then I just clamped this from 0 to 1. And then so I can figure out the cell's direction by doing a math.lerp of the float threes of the closest spline direction and the distance to closest point. So basically this means that if our t value is 0, then it's going to point in the direction of the spline. But if our t value is 1, then it's going to point directly to the spline. So again, this kind of goes back to that whole notion of, when you're kind of on the spline, you're going to be following the spline. If you drift away from the spline, you want to kind of navigate towards the spline first. And of course, there's like a little bit of a gradient. So the closer you get to the spline, the more forward it's going to allow you to move. And then we basically just go ahead and, add a new element to this array of a new flow field, and we just pass in the position and the cell direction. So the cell direction, as you can see, there's kind of a lot of like heavy calculations in here. So this is kind of like the majority of what's happening during that baking step. I think this get nearest point, especially with these values being maxed out like this, is really the most expensive part about this. And yeah, I'm not using like burst or anything here, so all kinds of fun things. Actually, I don't think I even could use burst with the spline utility, so there's that. So then we actually create our blob asset reference here. We go ahead and assign all the values on all the components and all this, and so that's basically kind of how we define that flow field. And then we're gonna do some additional drawing. We can do that. And then, well, I guess I kind of already talked about, how to sample them. But again, I can show you for the vehicle AI authoring. First thing that we do on update is we just get a reference to the flow field itself, delta time if we want it, drawing manager builder for some debug stuff. We do a similar entity query to the regular vehicle authoring. And then the first thing that we do is we get the cell just by doing a flow field.get cell at position. Again, this is kind of the helper method that I made on this flow field blob here. Again, where it just passes in the position, we can calculate the coordinates of the cell, and then this will index into that blob asset and give us that cell at any arbitrary point that we want to. Once we have this, then we can say, what the cell forward is just by doing the cell direction. And then, we can do some things here. What I'm doing is I'm taking the cross product of the steering direction and the cell forward. So the steering direction is basically which, direction the front of the car is facing. We can kind of compare this against, we do the cross product with that steering direction and the cell's forward direction, whichever way the cell wants us to point. So what the cross product does is it gives us basically a vector that's perpendicular to both of these vectors here. Now, in this case, if our cell direction is going to be, our cell direction is going to be facing one way, and the steer direction is going to be facing one way. And these guys are basically like both on the same kind of like XY plane here. So what ends up happening is the cross product is either going to be straight up or straight down. The difference is depending on, like which side the steer direction is versus the cell's forward direction. So basically using the sine of what I have this angle.y, which is calculated from this previous cross product, we can figure out if we need to basically, turn the car left or turn the car right. And so you can see that we're doing, a very similar step to what we had before. where we're just kind of modifying this current steering value, again, by our steering factor, basically how quickly this car can turn, multiplied by delta time. And so basically the sine of that angle, that y, again, is going to determine whether we're turning left or right, basically. I'm doing some other cross product stuff here. This is just kind of for some extra visualization. This is some things that I'd kind of started doing about kind of turning down the drift a little bit. I kind of just wanted to add like a little bit of kind of sideways force to kind of slow them down so they're not like completely skidding out. Still want to have a little bit of a drift, but yeah, I was doing some other kind of testing here to figure out how I could kind of push back on the force a little bit in kind of that sideways direction. Okay, and then yeah, after this, it's pretty similar. Basically, what we're doing this time around is we don't really care about if the player is pressing the forward button or not. We're just, in this case, it's just always pedal to the metal. They're always just going to be constantly accelerating forward. Again, I could probably add some better AI logic in here, but I think for a simple little arcadey style game like this, it's totally fine to just have them go pedal to the metal the whole time. Again, maybe could introduce some different logic in there later, but yeah. And then of course we'll just go ahead and set the visual steering and can do the same kind of debug visuals and everything like that. So if we come back over here, let's, I don't think I changed anything, so we can just enter the play mode here. And then, yeah, I'll just give you a quick one last little showcase into what this is here. So yeah, if you remember, I said that there was kind of some slowdown factor. So you see when I let go, it slows down the car pretty quickly. It doesn't completely stop in its tracks. Like it still rolls a little bit, but it stops it significantly faster than if I were just relying on the friction between the sphere and the ground, basically. So yeah, we kind of have this little lap here. We can kind of start racing these other guys and kind of follow along. Of course, we still jump off of them, and so right now it's the spheres that collide with each other. But I'm probably gonna change this up a little bit. So the actual like car visuals are kind of what collides with each other. So yeah, there's a little bit of fine tuning and stuff to do here. But again, yeah, it's kind of a simple little vehicle controller. This is kind of the basically basis behind this little project that I'm working on. And yeah, now's the time to actually get kind of some of the interesting gameplay in here. This is a little idea that I've had kind of for a while, and had an opportunity to actually do a little prototyping on it. So really excited to see how this turns out. So yeah, if anybody has any questions on this at all, I'd be happy to go ahead and answer them. Kind of the final segment to the show that I have after this is to just kind of do the dynamic allocation, which is the kind of fun things to share with the community, which I don't have these actually pulled up quite yet. So I can go ahead and grab these here while anybody queues up any questions that they may or may not have. But yeah, again, have been having fun, working on this little project here, and yeah, excited to see where this goes and share more with y'all later. And of course, like I did mention, I do plan to have this mostly open source, of course, removing some of the paid assets and things of that nature in there as well. So yeah, if anybody has any questions here, let's see. Have you been messing around with serializing loading subscene data outside of having it as part of the scene? No, not really. Yeah, some of the sub scene stuff. I know there's some interesting things that you can do with it, and I've seen people do interesting things with it, but it's not something that I've really had an opportunity to kind of play around with. But it is something that I certainly would like to do for sure. Let's see, where is the one other thing that I wanted to bring up? Here we are. Okay. So yeah, anyways, with that, we can go ahead and kind of start to wrap things up. A little bit shorter of a show today because, of course, it's just me in here today. But yeah, we can get into the dynamic allocation portion of the show, which is where we share some fun things with the community. So with this, the first thing that I want to share is we do this and this and this and this. So as many of you know, there is a rather well-known game developer named Jonathan Blow, whose name comes up quite often on this show. Currently, he is developing a programming language, which doesn't actually have a name, but the extension of it is .jai. And actually, you know what? I'll share this one first because this kind of makes sense to do it this way. So he was actually recently at this Lambda conference, which I guess is like a functional programming type conference. And so they interviewed him on stage, and basically talking about his programming language. Again, these are kind of people who are more kind of functional programmers, and John's language isn't a functional programming language, but I think they're just kind of interested in talking to people about some of the different programming languages that they're working on. So yeah, if you're curious about his language at all, he does have a lot of videos going back like 10 years ago now, about kind of the theory behind this language that he's been developing. And this is just kind of like one of the most recent interviews that he did just a couple weeks ago. So I'll go ahead and post this in here. So definitely a good thing to I'd recommend it. So the other thing that I wanted to share is this game, which is on the Google Play Store. I think you can also get it on itch.io, but it's kind of meant for mobile. And the game on itch.io is a little bit smaller. So it's called Heiko, Heiko, by this guy Mim Hufford. Cool thing about this is it is developed with Jonathan Blow's JAI programming language. So it's a really simple little puzzle game. I guess the interface of it is simple, but some of the stuff actually gets a little bit kind of complex as you kind of go along. But it's a really interesting game. It's one of these games that's similar to like The Witness, where it's a puzzle game, and it doesn't tell you anything at all. You just kind of have to figure out what all these symbols mean. It kind of introduces these symbols to you, and you kind of have to kind of come up with a little bit of a mental model about how these symbols work and interact with each other and everything. And I've been playing through it. It's actually a paid mobile game, which I think is really respectable that people are actually charging for games. It's only $3, so it's super cheap. And I've actually been playing it for probably about a week now, just every once in a while. And there's like some good depth of gameplay. I feel like I'm getting kind of close to the end. I don't know if it goes past this basically main screen, but it's kind of it's interesting. It's kind of like a little hierarchical game. So like you basically this is kind of the main screen, and then you click these kind of like open black hexagons, and then it'll have you complete like, I don't know, 12 to 20 puzzles or something like that in there. And then when it's complete, then this kind of fills in as like a white circle here. So yeah, it is pretty interesting how it all works. So yeah, it's a cool game. I would definitely recommend it. Again, I'll go ahead and paste the link in here. Again, all developed with Jonathan Blow's JAI programming language. So yeah, it's a fun one. I would absolutely recommend it. All right. So, anyways, with that, that is going to do it for this episode 22 of the Hot Path Show. Hope you all enjoyed it. Thank you all for hanging out, asking good questions, and everything like that. And yeah, don't forget that 2 weeks from today, we're going to be kicking off the Turbo Mace Games Dots Game Jam. Yeah, looking forward to it. Hope you're all as well. Yeah, have a great weekend, everybody. See ya. Oh, wait, nope, nope. Not done yet. Almost forgot. Do have to thank our Patreon supporters. We do really appreciate any support that you're able to give. Especially do want to thank the supporters at the CPU register tier. So thank you very much to eCool for your support over there. And yeah, do check it out for some different perks. Again, I did post a Q&A, a prompt for Q&A. So you can kind of ask me whatever you want. And then some other things for, again, if you want me to play your game jam entry on stream and some other cool things like that. And yeah, thanks, Wayne. Don't forget to like and share the show. All right. Appreciate y'all. Have a great weekend.